Airflow Sciences Equipment presents the MAP system, multiple automated probes for stack testing. The MAP system provides fully automated stack flow measurement. It can handle round or rectangular duct geometries and supports EPA methods 2, 2G, or 2F. Also, the MAP system performs wall effects measurements with EPA method 2H. A typical system will be installed on 4 test ports simultaneously, or it can be installed on 2 test ports if the geometry requires. There are many benefits of automated testing. The key is that you receive improved data accuracy and repeatability due to the automation of the test process. It reduces testing time and manpower and greatly reduces operator influence on the results. All data is recorded automatically by computer. No writing down any numbers. The system automates the data collection and the final reporting, including Excel and EDR formats. This is a typical MAP system configuration when testing 4 ports simultaneously. 1 probe and 1 PPU, or probe positioning unit, is inserted and mounted onto each test port. The PPU performs the actuation of the probe, translating it in and out to the proper locations, and also performs the rotation of the probe to find the yaw null position. All data is acquired, and a junction box is used to communicate between all the 4 PPUs. A computer connected through Ethernet ties in and records all the data and guides the test. The system can handle either an S probe or a 3D style probe. The PPU, as shown here, there's 1 for each test port with 1 probe, and it can support very long probes up to 18 feet or even 24 feet in some applications. The actuation is very rapid. The traverse for the translational in-out of the probe, and the rotational speed. The system can be handled and installed by 1 person on each port. The instrumentation is very accurate. A wide range of DP transducers are available depending on the range required. Also, atmospheric pressure, static pressure, and temperature and yaw angles are measured. Here are a few images of the PPU. Integrated bolts mount to the test port flange. Switches and lights and indicators are on the back side of the PPU. Every MAP system built by Airflow Sciences Equipment goes through a rigorous quality assurance program. Here's an image of a 5 PPU system mounted on our test bed, going through a 48-hour continuous operation of probe translation and probe rotation. The junction box ties in all of the data and performs the communication between the PPUs. It also houses a DC power supply, along with a purge air compressor, so no plant compressed air is required for the system. Any computer can be used with the Windows operating system. A Panasonic Toughbook is a preference of ours for rugged environments. A key to the MAP system's functionality is the software. It is easy to use and follows a very simple, guided path through the test. This is the menu structure. After setting up the system and preparing for the test, the operator zeroes the pressure transducers and performs a leak check. Much of the time is spent in the run test mode, where the data is acquired and the entire RADA is performed. The data is saved automatically, and there's even an option to do the calibration check of the transducers. Here are a few windows and screenshots from the software. This is a system configuration menu. This is where the individual test ports are prescribed, including which probe is mounted in each port. This is the test setup screen. This is where plant-specific data is entered, including the unit number, what load of operation, round versus square stack, and the stack diameter. This shows the automatic leak check. This can be done at the beginning of every test and throughout the test as desired. This verifies the integrity of the probe, the tubing, and the fittings, and all results are stored for quality control and reporting. The run test screen performs the entire test, 12 runs in many cases. All data is shown in real time and can be analyzed and quality control performed during the test. A test can be paused at any time to troubleshoot. At the end of a test, a calibration check can be run to make sure there was no transducer drift over the course. Finally, and immediately, a test report is issued in Excel format, and an EDR can be created as well. The system requires AC power and compressed air, but of course it uses its own compressor to do the purging of the probe system. This is a typical map installation on a test port. It mounts directly to each flange and is then self-sufficient. Here's another system mounted on all 4 test ports simultaneously of a stack.